Welcome to problem 2. It's very much like problem 1, so let's verify this first. N is an integer, of course, because 4 divides n. And that means we need to check that the square of the function equals plus minus, and then it's cz plus d nz divided by the square root of the determinant, which is n, and they are all positive numbers, so it holds with a plus. Next we compute this guy, and let's do it from the left. J of, I think it's the, it's Z first? Well, never mind. I think it's the other way around. I was wrong what I wrote here. I think we should have the matrix first. So the matrix comma Z. We actually we'll probably have to do it explicitly, so I'll just write it out what it is. And next comes phi of beta z and beta z is minus 1 divided by nz. No, that was alpha. It's az plus b divided by zz plus d times and we can reduce it . So they lie in the right hand positive real axis, and the product then has positive, no, they this lies in H, and that means that the square root lies here, and this lies here. So the product lies, this may be turned 90 degrees, So the product may be all the way here. And this result will always be here. So it may act, so what ends up here, we put down there. So it's actually a plus minus. Okay, that was a surprise. We'll see if it's any idea to do this. Well, next we multiply. Oh, what am I doing? Yeah, and then row to minus first. This is the opposite. So we need to find the inverse. We should have started doing that. This one multiplied by itself. So the inverse matrix is minus n divided by n. Then I think this is it. So we'll just multiply them. Minus n, naught, naught, minus 1/nth. That was not exactly what it should be. So we multiply this with n, so it should be 1 divided by n. And then this with minus 1, so it should be minus 1. And it has determinant 1/nth, yes. And then it's n minus 1/4. And then 1 divided by the square root of this matrix operating on Z. That is 1/nth divided by minus Z. And that gives the square root of n, and then the square root of z. This of course lies in h, so it's equal to this. So we need to correct this. Minus 1 divided by n to 1/4 square root z. And this one times that one gives d. And minus c divided by n. minus NB now that's going that way. A and next we have phi of beta z. That is, we operate this, but we must operate this z must be 1 divided by n and minus z. Oops. Times the other one, n to 1/4 square root z I'm looking a little ahead and that's worrying me, but now let's just finish this and then I'll make a break before I continue. So this gives square root n, square root z, so we multiply by that under the sign. So first the symbols, and then square root minus a plus minus plus nbz. That was my attempt at A. Next we assume 4 divides n, which means that, I don't know if you can, don't believe you can see that. So it lies in gamma naught of 4, and therefore gamma 1 tilde makes sense, and this result we already have. So I need to check that the matrix is right. Well, let's not care about that for the time being and just assume this result and find out what we will have. So if we write it gamma comma j of z, I think it's still, but never mind. I have exchanged gamma and z here. So we can see what gamma of that should, what this should be squared. No, just gamma of z. So it's minus nb, the symbol of a. Oh, that's weird. times epsilon a to minus first square root minus nbz plus a. All right, this last thing actually makes sense. But what we've got here absolutely doesn't. So I'll just check the matrix multiplication and then return. I actually got a bit tired before lunch, but these exercises are not only doing the definitions, it's learning the definitions and the concepts. So by doing them, one is actually educating oneself, and that does tire the brain, so breaks are needed from time to time. And here at the very end, it just got too complicated with all of it. We already have an ambiguity of sign, so whatever sign these symbols make plus minus 1, that's just eaten by this ambiguity. So we need to check epsilon a times epsilon delta, and you see a and epsilon d and epsilon a. A and d, their product gives unity modulo 4, so that means they have the same parity. They are either both equal to 1 or to minus 1 modulo 4. And that means in case A is equivalent to 1 modulo 4, they both give 1. In case they are equal to 3 modulo 1, both of them, we get I to minus first, so the product gives minus 1, still eaten by the sign ambiguity. So they have the same matrices, of course, but the function may vary by a sign.